Hi everyone. I'm really excited to be here today. My name is Anna. I will be presenting you the project that I was working on together with Luiza and Ariel University and Red Hat. Our project is focusing on penetration testing tool that we have created for securing hybrid cloud APIs. The goals of our project were first thing to explore the security aspects on hybrid cloud APIs to see what we have today in the research world. We wanted to develop a penetration testing tool that can help cybersecurity engineers and developers when they create and test new cloud APIs. We wanted to innovate a new solution, a proxy-based solution for penetration testing, a dynamic penetration testing on channel APIs in hybrid cloud. And we wanted to mitigate the risk on APIs, and in particular, cloud APIs from malicious activities and vulnerabilities that we're facing today. So why did we even choose to explore hybrid cloud? So there are some benefits and there are some challenges that come with using this complex architecture of a hybrid cloud. So first thing, we have the speed and scalability of a public cloud because we do use a public cloud provider on one of the entities of the hybrid cloud, which is very cost efficient. On the other hand, we have the privacy and control of a private cloud because we can control the private cloud that is installed on our servers. With that, we're having more entry points that a malicious attacker can come and access the cloud from. They can access it physically from the private cloud, and they can access it virtually to the private cloud and also virtually to the public cloud. With that, a complex hybrid cloud is a complex architecture. We have two clouds, and most of the times we also have the management platform that is managing everything, which means we have a more complex architecture to secure in this case. So hybrid cloud security. What challenges do we have with security on hybrid clouds? So we have data that is stored on all clouds, on the private one, the on-prem, if we have an on-prem, and the private cloud. We need to make sure that the data is secured on all of them in rest, in transit, and in use. We are focusing on channel API, which is the API that is standing between both entities of the cloud, and to make sure that all the data is secured, we need to use an API, but we also need to make sure that the API is defined with protocols and rules and access controls that users can access the data they are allowed to access to, and no non-allowed requests will pass through the API. So APIs today are one of the most distributed solutions of security companies, mostly cloud security companies, when they provide cloud solutions. So APIs is a great area to research because it's really popular today. We wanted to research channel APIs because channel APIs are the main entry point to hybrid cloud, and they need to be secure more than every other API that is running on those clouds. And we wanted to take our skills that me and Luiza had and create an automation tool that can rapidly test new APIs, warn the users if they have any problems with the API, any exposure points that shouldn't be there. So our solution is a reverse proxy based solution, which means this is a server that is standing between a user and the client and the cluster of the cloud, and is filtering and testing by itself the API. So the reverse proxy can get a API request from the client. It can analyze it to see if there is any malicious activity inside of that API request, API query. And also this proxy has a set of defined testing tests that it can execute by itself without needing a client onto a new API, and to make sure that the API is secure and doesn't have any problems before getting exposed to the outside world for clients. The reverse proxy hides the location of the cloud, which means that when an API request is sent from the user, it doesn't go straight into the cloud. It goes through the proxy at first. The proxy is analyzing the packet, filtering it. It can match it to the existing test to see if it can detect anything suspicious, anything that one of the tests would show to. And then if it's a legit request, it will pass it on to the cloud. And the proxy will have a set of defined rules, a set of examples, example API requests that it can match up to see if it can see that this new request is part of the common attacks that we defined to the proxy. So we would like to go over the risks that are in using Cloud Channel API. Oh, sorry. We would like to go over the common cyber attacks that we have implemented in our tool. The tool has a set of defined tests, a set of defined queries that we send to new APIs that weren't yet published to test to see if they can tolerate those common attacks. So the first and the most easy and common attack today is denial of service, DOS or DDoS. When this attack happens when a large amount of packets, or in this case, API request, is sent to a API endpoint and is overloading it with requests, making it unusable, taking it out of service. The next testing suite that we implemented was injections. Our proxy, our testing tool is sending to the new APIs a bunch of API requests full of injections. SQL injections, we have implemented cross-site scripting injections and JSON injections to see if they pass on to the cloud or the proxy is smart enough to drop them, or the API is smart enough to drop them, I'm sorry. We have implemented a testing suite for mass assignment, is where data has a lot of permissions on it, permission that it shouldn't have, and is giving an unwanted access to the data by the controls on the data. On the other side, we have access data exposure is when the controls, we have mass control, we have mass access control of users, which means we have a lot of users that shouldn't have access to this data. This was the intro. This was the research part. Now we will go up to the development part, where we have took all the tools that we had given from Red Hat and from the university and the technologies that we have on the market today to create the testing tool, the proxy, the whole environment, and to test new APIs. So how is our proxy even working? So first of all, we have an API call that is sent to the server. In this case, one of the clouds, the proxy, we have an API request that is sent. The API request has data. It has in the header, we have the IP source and IP destination. We have the IPs of both the private and the public clouds behind the hybrid cloud. We have the ports, we have the protocol which the request is sent by, and we have the payload, which is the data, the request itself that comes with the API packet. The reverse proxy gets the API and it executes security test rules on these API requests. This is an example of one of the rules that we have used. And from here, what happens is, if the proxy detects any malicious activity inside that packet, it will drop it. Sometimes it will also alert, depending on the security rules that we have on that API. If the proxy sees that the API request is legit, it will just pass it on to the cloud. Our security rules look like that. So we have the action, what will happen, do we drop, do we deny, do we alert, do we pass it on? We have the SIDs, which means the rules of how many times we can get the packet, what we're doing with the, how we check it. We have this signature of the attack that is executed by the penetration testing tool and the reverse proxy. And we have the filters that are applied by the user that have configured this proxy, I will give you 3 examples of API requests that we have given our proxy to run on APIs, and the APIs need to drop or allow it. So this is the first one. As you can see, we have an injection inside the username. This injection looks like a very common SQL injection, and for that reason, we will deny it. As we can see, this one also has injections in it. And for that, this one will also be dropped and denied. Here we see that we have a legit username and a password. It looks fine. And for that, this will pass on to the API. From here, it's not our case to test if the admin on the password really exists. That's already the servers. We only need to see that the query is not having any problems. So our main infrastructure was built from 3 main parts. We had the cloud environment. We had the penetration testing tool that was on the reverse proxy, and we had an API management system. So our testing environment, the dummy environment that we have created for ourselves, was 2 clouds. One is private, one is public. Both of them had 3 nodes deployed on it: a Node.js application, and my SQL application, which was used as a database, and a Golang application that was running the API endpoint on each one of them. We also had an external service between them that was running the channel API. We had the server on the right side, the proxy, and we had a UI user interface application that showed the users. It was a web-based application that showed the users the results of the testing. We executed, we had approximately, I think, we had 14 tests that we have ran on both clouds on the API. This is an example of one of the tests. The results from our tests were separated into 4 different categories. So the first category is true negative. We sent an injected API query, and as we expected, the test has failed and alerted us with a problem in the query. So that's a good one. On the other hand, we had a false negative. We sent a legit API request, but the test has failed and the API and the testing tool and the API alerted that there was a problem with that query. The third one was false positive. We sent a injected API query, but unfortunately, and that's the worst one, the test has passed with that. It passed the query, the injected query onto the cloud. And the last one, true positive, we sent a legit API request, and with that, the test has passed, and the API detected and the tool detected that the API request was okay. The technologies we used were we used a lot of technologies. We experimented a lot. We had two different versions during the 2 years of the research. So for the user application, the UI that the user saw, the web-based app, we used Flask, we used Bootstrap, we used Jinja, and we used JSON parsing to parse the results onto the user interface. For databases, for the user database, we used Firebase, and for the testing and the applications, we used SQL and MongoDB. For the server, we used Nginx. Everything was written and connected using Python 3, and the API pods were written in Node.js. And the APIs themselves, the APIs that we created by ourselves to test the tool were using Flask and Golang. Some of the challenges, so this project was very challenging, mostly because I was a bachelor student, which most of the times they don't do research in that depth. We had so the first challenge, and I think was the biggest one, was the environment setup. We had a lot of trouble creating a basic hybrid cloud environment to match our needs, mostly because of lack of resources. After we managed to create a public cloud and a private cloud, the next challenge was really connecting them. We couldn't find any platform to manage the connection between them. Choosing the operator to run the tool on and the technologies to run the proxy and the penetration testing. And yes, so biggest challenges were really making everything work and run, and not even the testing part. So the testing part, when we have a working environment, was much easier. So yeah, this was our project. The conclusions were, so first conclusion, I think, is the most interesting one, was collaboration. So we collaborated between a small university in Israel and a big corporate like Red Hat. We have contacted people from the university. We have contacted people from all across Red Hat, people from Red Hat research, R&D, security, and even quality engineering. We even got help from IBM with IBM Cloud. We also, it's not written here, but we also went to Massachusetts Open Cloud to ask for resources. That's an open cloud for students for research purposes. Next challenge, there are no solutions, existing solutions, even that similar to our solution. There are firewalls and there are penetration testing, automated penetration testing tool, but there is no a tool that has both of them, an active and the dynamic and active penetration testing tool that also queries, also filters queries at a real time. And the last conclusion was that our detect rate of our tool was really successful. On the APIs that we tested, we had a 95% match on the results of the tests. For future work, what do we expect to have in the future if we go with this project? So we would like to have a wider coverage attack on our testing tool, not only the 4 attacks that you have seen in the previous slides, but also other attacks. We would like to make this tool as a service, so really create a framework and a real service that can be added to Red Hat's toolkits. And we would like to use the power of machine learning and artificial intelligence modules to analyze API attacks that are new or are not predefined in our proxy. So yeah, this is about the project. We have time. I would like to tell you about myself. During the research, I was a bachelor's degree student in a real university. I was doing computer science and cybersecurity. I was working at Red Hat as an intern. Currently, I'm pursuing my master's degree in cybersecurity risk management here in Washington, D.C. I'll let Luiza introduce herself.
Yeah, everyone. So I was mentoring Anna during her last project in her university study. It really was her last year project, and it was her first research project, and she did it great and presented amazingly today. In general, I have like 15 years in the security industry, and currently I'm working for another company also for leading application security. And of course, we would like to get any feedback and questions about our work.
Yep, thank you, Luiza. So I would like any questions from forum.
The presentation is very good, and yep, it's insightful about the API attacks. And if you don't mind, may I know what kind of machine learning module you guys are planning to use it for your project or to detect the API attacks?
So currently, we didn't use any machine learning modules, nothing, because I haven't had any experience with machine learning and AI. I was mostly doing cybersecurity in my school. We would like to implement that because right now what we have is a predefined set of rules that by those rules we check if a attack is a malicious. So for example, for DDoS, what we have, we count the packets, we count the amount of we count the amount of packets sent. We look at the API, the IP addresses that the packets are sent from. We analyze that, so we know what we're looking for. That's the problem with predefined. We know how to extract SQL injections from API requests. That's predefined. With AI and machine learning, we can detect unknown and undefined attacks in our tool, which means if we see a amount or some type of malicious activity that we cannot really pinpoint on what attack it is, but in general, this amount or this query looks suspicious, the machine learning can detect that. It won't be perfect, but at least me, I think, Luiza, we don't have any experience with machine learning and AI. I cannot really say what we will be expecting from that.
So I will just add, because this is a reverse proxy, so the benefit there is that we collect a lot of data, and we will be able to build the features in the machine learning and teach the machine how to identify resources and how to identify an attack on a resource. So this is like the idea.
Yep, that's great. Thank you. Thank you very much.
Sure. So yeah, if I have a minute, I would like to really say a big thank you to Red Hat and for the support. Red Hat Research, the RIG of Tel Aviv. A big thank you for Stav and Idan for supporting us during that time. We also had another partner that worked with us on the second year of this project. His name is Aviv. He was also a student in Ariel University and an intern in Red Hat. He really helped us with creating the cloud platform when we tested everything. Also, I would like to thank my professor, Dr. Amit Veer from Ariel University, for the help. Aviv is coming from Ariel University too. And yeah, I really enjoyed working with Luiza, with the university, with Red Hat. I hope we will have more to this project and more upcoming projects with both the university and the company. Do you have any last questions?
I'll show them our emails so they will reach out to us.
Those are our emails. This is my Red Hat email. This is Luiza's private email. Feel free to message us to email us your feedback, your ideas. We would like to hear more. And yes, that's it.